Hello again, all my Bates-Rich friends. I hope everyone is doing well, and hello to all my adult friends and family watching on Julia's Facebook page. All right, guys, just like with our iodine clock reaction, this one takes a little bit, so I want to start it now, and then we'll talk about what we're doing and all that good stuff. The first thing I have to say is this is not an option. This is do not do at home. Again, I will get into that. This is just for me to do and for you guys to watch. This is very dangerous. Okay, so before we start, the first thing I'm going to do is take this piece of paper. It has a circle on here so I can remember where I'm going to leave my thumbprint. I'm going to take my thumb, press it right down there in the middle of the circle. Okay. Now I'm going to go outside and actually do this reaction. Again, you are not doing this, only me. Okay, I'm going to put the paper down here. In this glass, I'm going to put some iodine. With some hydrogen peroxide. Use a lot of hydrogen peroxide, don't we? Okay. And then just a little bit of citric acid. Now I'm using lime juice. You could certainly use lemon juice, orange juice, any kind of citric acid. Mix it around. I want it to get on the sides of the glass too, so that's why I'm swirling it. And then I'm going to, Marshall, can you get me, oh never mind, I got it right here. I'm going to discard this liquid. I'm going to try to remove any excess that's dripping down the sides. And I'm going to set it right over that circle. And we're going to leave that there. Okay, we'll come back to that in a little bit. Oh, I locked Dudley on. Dudley, come on. Okay.
Good boy, Dud.
So, what was that all about? Well, this is one that I didn't want to do when we did the other iodine reactions, just because, again, this is very dangerous. What I'm doing is you put the iodine in the glass with the hydrogen peroxide and the lemon juice, or the lime juice, and that vaporizes the iodine. Now, iodine is toxic. It means you cannot eat it, you cannot breathe it in. So that is vaporized iodine. We're leaving that outside in the air. We didn't get near that. We're good. You guys don't do that experiment. All right. So when, oops, I forgot I wanted my iodine. Be back ready. Okay. So when we did our first iodine experiments, I showed you, I wanted to go back and cover a couple things. I showed you that you can take an aspirin and turn the aspirin that dark color.
Can you still eat the aspirin?
Because iodine cannot be ingested, so I could not take this aspirin right now. It turns that dark color because it has starch in it. Well, you know what else has starch in it? Is paper. So I tried to wipe off that glass before I flipped it upside down, because what's going to happen is any excess that drips down onto the paper is going to turn the paper this color. What we are doing, guys, and what I'll show you when this one is done, is I'm exposing my fingerprint. When I had that blank piece of paper and I put my thumb down on it, I was leaving what they call a latent fingerprint, meaning I left it behind but you can't see it. We want to turn it into a visible fingerprint. Okay. So, yep. So again, I didn't do this because the vapor that's created is toxic. It stains the paper. So this is something that you would normally do outside or in a hood. And because you guys don't have those in your house, if you do, we got to hang out, let me know. But almost everybody does not. So you're not going to do that. All right, so let's talk about fingerprints while we're waiting for that reaction to finish. Marshall, let's take a look at this. What are the different parts of a fingerprint?
The arches, loops, and whorls.
All right, very good. I'm impressed. I was actually asking that rhetorically, but yes, here they are. Good job remembering. Loops, whorls, and arches. So everyone has a unique fingerprint, right? Mm-hmm. What about identical twins? They have the exact same DNA. Do they have the same fingerprints?
No.
They don't. Very interesting. So fingerprints are actually more unique than DNA. Pretty mind-blowing. All right, why when I touch that piece of paper, am I leaving skin on that paper? How am I leaving a fingerprint?
They're in your fingerprint. They're like little dents, and there's the oil on your skin is left behind, and it leaves a mark.
Right, so there's oil on your skin, and when I'm touching that paper, I'm leaving behind the oil on my skin that's being touched by my fingerprint. Very good. When do we get fingerprints? Is that something that after a month after we're born? Or?
In the 21st week of developing in the stomach.
Wow, so when you're still in the womb. Okay. And I've heard that fingerprints are determined by the rate of growth of a finger and the amount of amniotic fluid in contact with the finger. So there's different factors that vary into determine how a fingerprint looks. Okay, and let me see, what other questions that I want to ask about fingerprints? Oh, why do we have fingerprints? What's the purpose of a
To
fingerprint?
help you pick things up, because the little grooves in them,
Okay.
and to help you feel. You could do both without them, but not as well.
Interesting. So those little ridges give you a three-dimensional surface
Yeah.
that helps you grasp things and your sense of touch. Interesting. I think you're right. Very good. All right, well, I think it's been enough time. Was there anything else that we wanted to talk about? Okay. Let's go out and see if that reaction did a better job than this one that I tried earlier, just as a sample. Okay, remember, you got to stay back. Okay.
Yes.
There you go. There is my fingerprint on the paper. Pretty cool, huh? All right, so that's just like forensic science right there, guys. That's pretty much it for the iodine fingerprint reaction. I hope you guys enjoyed that. I will see you all soon. Remember, science is awesome, and so are you. Bye.